Um, I'm very happy to be here to share some of the research study we have back in University College London. By the way, thanks for the invitation. So I think Pavel and I know each other when we were PhD students in Netherlands. So we're both of us working on information retrieval, and as I said, I'm very happy to be here to share some of our studies. So today, what I want to focus on is real-time bidding-based display advertising. I know a lot of you guys here working on sponsored search, on advertising, because advertising is really one of the major revenue stream for search engine. And so before I start, just for people who would not really know University College London, so UCL in fact founded in 1926, and so it started with London, called London University, and the idea was to open up sort of education to the wider social groups, where in that term, the Oxford, Cambridge, they have some restrictions in terms of who they would able to permit to their college. So after that, we sort of formed this University of London, and actually give out the University of London to that sort of affiliation. Then that's why we call it University College, is because we started with as a university. So UCL, in fact, we rank irregularly in top 5 in UK, and last year's sort of research excellence framework, this sort of UK government-run research exercise evaluation, so that in fact UCL rank the second, and our computer science basically run in terms of research excellence. So far we have 22 Nobel winning prize winners. I work in University College Computer Science Department, and I specifically working on quite a number of topics, include information retrieval, computational advertising, collaborative filtering, and also personalization. So I'll give a summary of what I'm gonna talk about today. And because the limited time we got, so we're gonna focus on real-time bidding. And the reason I think the real-time bidding is a nice topic is because it's quite new, relatively new, and there's a lot of interesting, insights, a lot of interest problem, and a lot of potential sort of as a research domain, as a research topics. I think there's a lot of things that need to be done. So I would have very quick introduction to real-time bidding, and then I will start with sort of our initial study on the exchange mechanisms. We measured the user behaviors and bidding behaviors, try to sort of provide some general picture about the problem and the insights into the system, and that actually help us to guide what are the problems, how can we using computer algorithms to solve those problems. And then I will move to this the buyer side, looking at bid optimization. So I'm going to talk about two research papers we recently published in KDD. So one talking about this, how can we optimize, for example, conversions, clicks, based on the budget constraint. And then I will move to talking about a very sort of unique problem in the display advertising, and map it to financial market. Say, can we have a computer algorithm help us to identify some of the arbitrage opportunity, and actually can make use arbitrage opportunity as well. And then I will move to the sales side, is look at it for publisher perspective. What are their problems? So I was talking about this the possibility to establish a forward market and possibility of even create sort of futures and options exchange. And I will conclude with the pricing model that we started in the past. And so for people who are familiar with display advertising, they would know that in the very beginning, the display advertise is all about the contextual data. So here is an example where in a typical website like a news paper, news portal, where you have the content and people go through the content. And you want to put it, normally you want to put ads on the right side corner, and you want to increase the probability that the user is going to look at the ads. How do you do that? You basically say, okay, look at the content to see there's a match. So people tend to look at that particular news item, are more likely to read that particular or see that particular ads. So they try to do this content match to see whether that particular campaign is matched to that the content. And in most cases, and they are premium publisher dealing with premium advertiser, so they have like negotiation in terms of deals. So they basically package their inventory together based on, for example, the category, content, or even the user. But the idea is that they package it together and then to pre-sell those inventory, and then down to the algorithm to do the scheduling to say, in what impression I should show what ads campaign. So the main matching here is based on the content. And then since 2009, and there's a concept called real-time bidding happens. That was because this premium publisher, premium advertisers, they done their deal, but there are some sort of leftover impressions. So how can publisher dealing with this leftover impressions? For these individual packages, they're probably not really useful. They can't package them together. And maybe the premium advertiser not interested in that leftover impression. So what they do is that they created some sort of ad networks, a bundle, and aggregate those impressions together. So when the ad networks created and grow, and then there's a problem for those ad network to interact with each other. So that's why they come with the ad exchange. And when the ad exchange, is created and people are able to, in fact, so in the ad exchange, what happens is that the ad exchange runs this per impression auction. So because of that, the publisher would be able to sell the ads per impression. And because of they would be able to sell the ads per impression, the advertiser, in fact, would be able to target to that particular user. So in this particular example, this is my personal website, and I visited it last time, and you can see that this particular ad provided by Google was not directly relevant to that particular relevant to the content at all. It's actually targeted to me, the specific user behind that impression. So I remember at that time I was actually working on some like a home DIY stuff. I was actually looking for some light solutions, and I actually visited that very website. So since then, this particular website keeping stalking me, keeping tracking me whenever I go. So even I go to my personal website, they sort of show that particular ads that I have seen, and until I convert somehow. So that's to show that although it's really arguable whether that sort of stalking is good for the end user. But the recorded retargeting is just retargeting to the user that's in their data pool, cookie pool. So this simple retargeting technique, in fact, can increase the click-through rate up to even 3 times. So it's the advertiser feel very exciting because that's, they can target to that specific user. Publisher also feel very good because this leftover inventory used to be, not really useful at all. But because of real-time bidding, they know the user, and then they can target to the underlying user. So here's another example. If my students, were visiting there, actually they will show different ads. So in this case, just somehow the guest that particular student was interested in travel, and then this Booking.com has a higher bid, therefore win that particular impression. So how big the real-time market is? I'll just give you a bit overview, the data we know. So AppLexus is one of the largest RGB exchange, and they see more than 30 billion impressions in a single day. And there's a public company called Rubicon Project, and which is more or less supply side platform, which I will talk about what is supply side platform later. So they has hit these. I think that this year they had hit 1 trillion impressions. So there's some sort of survey company actually find out that in fact the global real-time bidding market is still sort of growing, and the forecast there will be around 40% annual increase. And here is an illustration to show how it works behind the scene. So let's say the user visits a website, and then that triggered a bid request. So that bid request contains contextual information. For instance, what is this website about, the URL, the category, the publisher ID, and also the user information, like a user terminal, is a Chrome browser or mobile, and also the user cookie IDs that this particular publisher has. And send this to Exchange, and at Exchange basically create an auction for that, and send the same big request to all these DSP platform, demand side platform that connect to them. So there potentially might be even hundreds of DSPs connect to a single exchange. So the demand side platform is really the platform where they hold the creatives normally, and they help advertiser to come in with a bidding decision, whether they're gonna bid or not. So when they receive this bid request, what they do is that in some of cases they might have their own data, then they wouldn't need to query the additional data. If they don't have the cookie data, they can go for the data management platform where they can say, this is the cookie ID, and tell me more about this user. So obviously they have to pay the DSP to get that additional information. So the DSP may have that cookie data and said, okay, I know this guy, says our estimation is a male and around 20, and they like travel. And those information this publisher, the advertiser got. And for example, maybe one of the advertisers is interested in users who are who's interested in travel, so they can actually put a higher bid. And so they basically send a bid response with a higher bid for that particular advertiser. But other advertisers might also send their bid response, and together with ad creatives as well. So ad exchange basically look at those bid responses and pick up the one has the highest bid. So they basically conduct is called second price auction, which is quite similar to what happens in the sponsor search, where people using the called generalized second price auction. And then pick up if one of them won the the auction and the exchange usually, but it may not be the case sometimes, is that they send the winning notice, say, okay, you won that particular auction, and this is how much you need to pay. Then, at the same time, these ads, the creatives actually send back to the publisher, and with a tracking, pixels, etc. So once user sort of see the ads, and when the ads creative loaded, and then the publisher would be able to track whether the creative has been loaded or not, whether the user has been clicked it, etc. Or even there's a cookies in that particular publisher website to track whether the user has eventually converted or not. So this information eventually become training data for DSP to optimize their campaign, but also can be used for reporting purpose. For example, how many clicks you generated, how many conversions you generated, and then report back to the advertiser. So this is how the bid the auction works. So bear in mind that this happens within 200 milliseconds, so it's very quick. The end user hardly notice the what's going on behind it. So this essentially creates a sort of new ecosystem, I would call, for display advertising. So on one side you have publishers, on the other side you have advertisers. So in between you have quite a few intermediary players. For example, you have, as I said, this access. So DSP is demand side platform, help advertiser to run the campaigns. And on the other side, you have the called supply side platform, which is really a platform, help a publisher to manage their inventories. And in between is really the exchange, which run the auctions, and to send this bid request receive bid request from SFP and send back the request to the DSP. So it becomes sort of central point in this ecosystem, and everybody connect to them. But of course, they have multiple exchange. Those exchange they are connected to each other as well. So on top of that, they might have a third-party data provider, as I said, they called DMP, data management platform, which managing cookie data, and ad serving, and ad agent, and other third-party companies. So now the question is that given this new ecosystem, what's the data there? Do we have any insight into what's going on there? So sorry. So we conduct our first sort of measurement and provide a bit of insight into the new ecosystem. So first, I would like to talk about is a mechanism, the auction mechanism. So for people familiar with sponsor search, they obviously know that in the sponsor search situation, they do second price auction, and in fact it's called generalized second price auction, where you have the ranked list. In real-time bidding situation, it's slightly different, slightly more complicated, where the publishers can specify, not only can specify hard floor price, which is similar to the floor price in sponsor search, but also they can specify the soft floor. So the hard floor is really this sort of reserve price, meaning that if you want to participate in that auction, you have to have a bit higher than that reserve price. And the soft price is really for decide how much eventually the advertiser want to pay. For example, if the soft floor is very high, if it's higher than the second price, then what you really do in the end is that you would charge based on this soft floor rather than the second price. So to give the publisher a bit of flexibility in terms of how to decide the final payment. In some situations, you can set the soft floor very high, so that even higher than this, this winning price. The winning bid. So in that situation, the advertiser would charge that winning bid. So essentially, when you set up the high soft floor price, is a first price auction. because you paid what you bid. You pay you pay basically on that the bid. So because that sort of a combination, we find that at least in our data set, we find that 45 first price auction actually. So first price auction actually the percentage of the auction is 40. First price auction is 45, and in terms of budget-wise, it's actually slightly more than the second price auction. So that might suggest that if the second price is truth-telling, second price auction has this nice property of truth-telling, and then maybe good for everybody, then perhaps given this soft floor and then have this first price auction embedded might not necessarily to be a good thing. So we will see whether that percentage will change in the future. So this is a sort of an auction. Then let's look at these the bids that people provide. Let's look at the winning bids. Okay, to see whether there's a pattern here. So we find that if you look at we look at these winning bids and the against the time, for example, the day of the hour of the day. So we look at it, and clearly there's a pattern, and in fact, these the winning bids are peak at morning, and if you look at the average, winning price as the peak one is always around at 6 and 8 a.m. However, I will show later in that particular period, if you look at the number of impressions, in fact, is not really the peak in that day. So here's a sort of plot. If you look at this, the blue curve, which is against hours, the blue curve is really the number of impressions. You can find the peak actually is at noon, not in the morning. So that might suggest that it's not the supply demand is not perfectly matched. So that means that you have a higher bid. The higher bids might due to the competition itself, but this actually the number of impression generated, the peak is actually a bit lagged. That happens at noon. So the more bidder in the morning is that which can be explained by the situation because there's in the DSP people specify their target rule and that's it. So they specify their daily budget. And in some cases, they don't really have this budget pacing set up, meaning that you just spend the money in the morning, and then in the afternoon, and when they run out of money, and they don't do the bid. So that's why they have a sort of huge demand in the very beginning. So that demand does not reflect the number of impressions that happen. So that might mean that they definitely need some sort of optimization. So let's look at this. If you are a clever DSP, what you do is that you might have set up the daily pacing, say, because that the price in the morning is very high, and in fact there's more impression coming in the afternoon, and why not? I would have more bids in the afternoon so that I might be able to get a cheaper price, and with the impression that I want. So this is sort of a look at the supply demand, and then look at the conversions. So in conversions means that eventually that display, that clicks lead to people actually buying something. So the conversion could be contributed to credit to two situations. One is that called post view, is meaning that the user saw that particular ads, then eventually converted. The post click is meaning that then the user actually clicked that ads and eventually converted. So we look at this the counts in terms of how many hours when the user view that particular impression, or how many hours when the user click that impression and eventually lead to a conversion. You will see that in fact there's a sort of a like a distribution on that. So that means that user might take time eventually to convert. And there are some patterns. For example, we find that in certain cases that people, well, quite obvious, people are less likely to convert during the late night. But also we also observed in other cases for certain campaigns, for example, gaming campaigns, people tend to convert in the weekend. So people tend to click and view on Saturdays and actually convert and put their money and do the gambling on a Saturday and Sunday in UK, which is true because the most of games like football games happens in the weekend. And so for the DSPs, in fact, there are quite a number of ways to optimize their campaigns. One of the ways is that set up this called frequency capping, meaning that I would set up cap for a particular user. I only target that particular user for, let's say, 5 times, not no more than 5 times. So we did a sort of study in terms of the how many times that users see that impression that actually convert, whether there's some sort of relationship. So we found that it's really campaign dependent. For some campaigns, some campaigns that's, for example, the campaign 1 in this case that, the users, by average, if users see impression like 6 or 10 times, they have more chance that converted, where in other case, that might be 2 and 5 times. So that means that you definitely need to look at the data and see that for individual campaigns and to figure out what would be the right optimal caps. So there are also other things you need to consider. For example, the recency. So is that when we're talking about conversion, how this particular view or particular clicks is credit, then we need to come up with a conversion attribution model. So in most cases, people using like last touch. So this touch could be view, this touch could be click. As long as the last time the user saw or clicked the ads, and before they converted, that particular view and clicks would take the credit of that. I mean, the importance of the attribution model is read because in most of some of the time the DSP get paid based on their campaign performance. So they need to figure out that what sort of campaigns eventually will lead to a conversion. So that's why the attribution is important. So now back to the recency, is that you can see from the campaign 1 that in a lot of time that people see the ads then convert within 1 to 5 minutes. But not necessarily to everybody do that. You can even more than a month. So that means when the user look at that particular ads and might be converted eventually by the product in a month's time. So that means that you might have some sort of number one, you need to have a sort of strategy. Say, I need to track that the performance over at least a month's time, in order to track whether the performance of the ads. Sorry, and using some clever algorithm to optimize that. But on the other hand, you would be able to help you to come in with some sort of recency cap, whether you could cap that for whether you want to cap in a very short period of time or what packet longer. So those studies definitely would help you to make a right decision. So we have a paper published. So if you're interested on that, we have more analysis on that. If you're interested on that, understanding how mechanism and what are the sort of insight into the data we analyzed, and you can look at our paper. So let's move to a buyer side, saying that given that there's quite a few problems in DSP to optimize their bidding strategy, can we come in with sort of a clever solution? allow, for example, computer algorithm to help us coming with a clever bidding strategy? If yes, and what would be the algorithm we were able to come up with? So let's start to look at this the bidding optimization problem. So as I said, in the ecosystem you have a DSP. So the DSP, really the core part of that is called a bid engine. It's the one that is going to receive the bid request, and based on the forecast, based on CTR estimation, conversion estimation, and start with coming with a bid price and send it back. So for the bid engine, in fact, a lot of things need to be done in that particular engine. For example, you need to have a feature engineering, collecting the bid request data, historic data, to see what are the features that I would be able to use in order to sort of properly assess the value of the impression. So the value could be, whether user going to click, so it's click-through rate, probability user going to click, the probability user going to convert, and sorry, and I will look at, for example, my budget. How much money I left, and also I will look at the forecast. Do I see this impression a lot in the future, or do I see is this impression very unique? Then I would definitely need to get it now. So to look at the future opportunities, and based on that you make a decision. And the end result of that is really the bid price for a given impression. So in a more abstract level, the problem is that you can consider the bid engine as a black box. The input is a bid request, where it consists of maybe thousands of features about that particular impression. The users, your budget, the historical data, the data from DMP, the contextual data, etc., etc. How can you come in with a bid price? So what you can come with is that you want to maximize, one of the formulation is that you want to maximize certain KPI. So this KPI could be clicks, number of clicks you generated, or number of conversions you generate, or maybe a combination of two. And subject to certain constraint you have. So this constraint could be your budget constraint. So it might be other constraints as well. And if we're doing that, we can come in with a sort of a mathematical formulation where we have expected value of, for example, number of conversions, we'll have expected number of clicks. So the theta here is that if you're interested in that, we have a paper again published, so you can look at that. So I can give you a bit of explanation here. So the theta here is the probability user gonna click. So we basically, based on that, the uncertainty is really from that particular probability user gonna click. Based on coming with a sort of a expected value of clicks overall over the period of time. And subject to the constraint that for that period of time, how much money I have. And the solution, in fact, we're using this calculus variance coming with sort of a solution to derive a bid function. So the bid function really is that, if you look at this, is taking a CTR estimation and transform it into a bid value. And this transformation is not necessary to be linear. And in fact, it's a saturation function that we come with. So if you look at the equation on the right side, it's actually our bid function based on the reading function we learn from the data. So the left side is really the reading function, really is that which specifies that how likely, if I put a bid £5 or £3, how likely are gonna win. So this can be learned from the data. It could be per campaign level. It could be sort of global level. It depends on how many data you got, how accurate you want your model is. the nice thing of our model is that we don't really need to specify the relationship between, pre-specify the relationship between the bits, the CTR estimation and the final bit value. We just provide sort of, this is our reading function, and put in our formulation, a formulation that basically tells you the exact form of the the exact form of the bit function. So you can see that it's really on the right side is a sort of a saturation function related to our theta, but also have a few parameters. So those parameters can be learned from your data. Sorry, to get insight into why we have this bitting function. You can see that we can compare to the linear function. So the basic linear function is that you have the CTR estimation, and you have a bit value. So they come with a linear relationship. So if you have higher CTR estimation, then you might have a higher bit. but our algorithm is that we tend to put these bits on the low, move our bits, move from this higher CTR to the low CTR cases. So in fact, the end result is that we tend to bid more. We tend to have a higher price for these low CTRs compared to the linear ones, and we tend to bid less for the ones that have higher CTR. So the end result actually is quite good. That we will show the performance in terms of number of clicks generated, number of conversions generated. We are significantly higher than the linear one, and we guess the reason. One of the reasons was that because we tend to tend to have more low CTR impressions. Is that for the money budget-wise, in fact, these, although they relatively have a smaller CTR, but they are very cheap. So as I said, we aggregate them together. In fact, for the cost, if it's more cost effective than you actually compare a bit to the the higher CTR one. So we have this is our offline test. We show that the ORB1 or ORTB2 optimal bidder, it's in terms of generate clicks on the left side, in terms of generate conversions, is as far more than those baseline that we considered. And we did also an online test. We collaborate with a Chinese DSP called IPNU, and with the 3 days online trials, we basically had the highest score. We used our algorithm had the highest score. And in their competition, the object function, the KPI is really say the number of clicks and plus this number of conversions. So we basically achieved the highest score, much higher than the second one. So that indeed shows that not only the offline data, but also in real situation, it works. The next I will move. Next I want to talk about is statistical arbitrage money. So it's sort of based on our previous model, but working on more complicated case. So think about this a real-time bidding situation and whole ecosystem. You will find that it's still in a very early stage. If you compare with the financial marketplace, think about this real-time RGB market. If it's a market, you want this market to be informationally efficient. So that means that you need to have a transparency. You need to have sort of a make sure that everybody knows the information. If you have that, most efficient, transparent sort of market, that the resource allocation would be more efficient. Obviously, that's in theory. But in practice, if you look at the current RGB market, it's not really transparent. So, for example, the advertisers, when connect to the DS exchange, in some cases, they only get aggregated report. They don't. Some cases they don't even able to get like per impression data. You have to track yourself, and then you have to sort of put effort to getting it. And for some of the impression you didn't win, you don't really have that information at all. So those things that because of that, then each individual, for example, advertisers, DSP, they only have a global view. Sorry, they only have a local view about the marketplace. So that means that definitely the information is not transparent, it's not efficient. And I'll give you an example. Let's say, potentially they might have two types of market, which is CPA and the CPM market. So in auction, in the exchange, real-time bidding auction, usually in most cases it's charged based on cost per mile, per 1,000 impressions. So you served my ads for 1,000 times, 1,000 impressions, I pay you a certain money. So based on that. However, there's a mismatch between this price scheme with what advertisers really want. For advertisers, they want a direct response. So they want to acquire new users. So what they typically want is that the payment in terms of, for example, cost per acquisition. For example, in the game industry, I might want to say, if you help me acquire a new user, I will give you £50. So that's sort of a price scheme usually drawn between advertiser and the RGB intermediary, like, for example, the trading desk, the ad agents, and DSPs. And now those intermediary partners, they usually do is that they buy these CPM-based impressions and serve those CPA-based campaigns, and to work out that whether there's some sort of a revenue profit margin in between, and then they make profit out of that. So we basically think, okay, can we using computers to do the trading? So in other words, is it possible the computer would be able to identify that arbitrage opportunity and able to actively do the bidding and to maximize the profit for the intermediary? So we have to be careful on that when we name our model as an arbitrage model, because in the finance, people sort of say that arbitrage is a bad thing. People tend to make money by speculation. They don't want. People actually blame because the financial crisis due to that sort of behavior. But here the situation is slightly different, because these arbitrage is in fact serve his purpose. There's some purpose here. It's not just to make profit. In fact, it's actually help the potentially close the gap between the CPA marketplace and the CPM marketplace. So try to sort of make this market to sort of even eventually. So for that perspective, indeed, we definitely need to have statistical arbitrage modeling in real-time bidding scenario, because the market is not the market here is not transparent yet. It's not efficient yet, and the actual, when you do the arbitrage, you actually deliver that particular ads. You don't really say take profit by buy and sell stock, and you do nothing. So here, the middleman actually serve the ads for advertiser. So so that's actually given a justification about this approach. So so in short, if you look at this, it's that in fact what the computer do is nothing but a meta bidder. So that means this bidder managing a portfolio of campaigns. So just like the hedge fund manager manage a portfolio of for example, assets, stocks. So you're managing it, and there's a sort of a bid request come in. You basically decide, okay, for each campaign, which one I should bid and how much I would bid in such a way. I would maximize the return for my portfolio. So if they find that there's a statistical arbitrage opportunity occurs when, for example, this, the CPM cost per acquisition, the cost that you pay, is smaller than the payoff you will get from the advertiser, you actually spot there's a arbitrage profit margin, and you should bid. Of course, that is in a statistical sense. You cannot deterministically know there's a profit margin. So everything has to be in a probabilistic sense. So how can we come up with a solution? So we basically, if you look at it, we basically change the the object function. The frameworks do the same, but we change the object function and also change our constraint. So here is that we have additional parameter to optimize. So apart from the bit price, bit function we want to learn, but also we have we call it campaign value volume allocation. So basically is that the probability in my portfolio, the probability I would bid for this campaign. So to basically give a sort of a volume allocation to the campaigns. Or in other words, you can consider that how important that particular campaign towards your profit margin. So we have these two parameters you want to learn. We want to maximize our expected return. So instead of expected clicks, expected conversion, we want to maximize expected return for myself. And there's some constraint. Obviously, you have budget constraint. You obviously can't spend all. You can't spend all your money, but it's better to spend on some constraints. There's a risk behind it. And you need to have risk control, meaning that when you have estimation about your return, how reliable that estimation is, what sort of risk you have. So that's need to definitely need to consider. And otherwise, this expected return can be very high, but there's if you really willing to take a more risk. So we added this risk control. This is slightly more complicated optimization problem, and you cannot sort of find an analytical solution. So what we do is that we do a approximation by using a generalized EM algorithm, the methodology. So what do we? You can consider this, for example, you can consider the weight for the campaign volume allocation weight parameter V here as a sort of hidden parameter. So you would have each step try to estimate, and once you estimate that the value, you can fix that. Say, I know that parameter, and when in the M step, we basically maximize the object function and try to get the big function. So and then you do this iteratively, and then you will in our experiment actually is quite convergence pretty quick. Only few iterations. So in summary, that in the M step, you fix the V, the weight for campaigns, and you turn this, you learn this, bit function. And then in the E step, you would fix this bit function and then try to turn this the V, the value, and eventually we'll get the result. And this again, this is a sort of you can do this offline and to learn that bidding function, learn the weight, and when you actually do the bidding, you just using that function and using that V and do that. So it's going to be very quick during the when you run this campaign. So we did a bit of test on offline. So we have two settings. One that you might have this payoff margin is very small, which is we call hard payoff. And also some situation, with more than some situation, it's relatively easy to get a higher, payoff from the conversion from the advertisers. And we look at the two situations. You can see the SAM is really our, algorithms with different configuration. You will find that in terms of revenue, profit we generate is actually quite high. And also, we will also test that whether the portfolio optimization, the weight we have assigned to the campaigns, whether it works. So we actually update our model every 6 hours. During the process, we find that if you look at this, the top figure, it shows that at the moment we have, in the graph we have 4 campaigns. You see that the allocation changes over a period of time based on the data we received from the exchange. And also this meaning that this really the weight adapt to the situation and try to optimize that the revenue. And also we did our online A/B testing as well. So we need to make sure that the algorithm we developed works in the offline situation, but also in online situation where the situation might be more complicated. We need to make sure whether indeed our algorithm is a good one, is a better one, and in the real setting. So we work with a mobile DSP. We test our SAM algorithm, statistics arbitrage money algorithm, with their basic algorithm. We test that in terms of generated net profit, we obviously much higher than theirs, and in terms of conversion rate, we also high. A bit of look at this, the data you will find and why our algorithm works. So if you look at the number of impression, we actually won. You will find that the number of impression we generated, in fact, is less than the baseline algorithm. But look at this cost per mile. The average sort of cost a 1,000 impression, we actually relatively high. So that means in this particular algorithm, we actually bid less, but we actually concentrate something good, something better. And the end result is that, in fact, we have much more actions. And by overall, this eCPA is the average cost per acquisition, is that we have much lower, cost per user acquisition. Therefore, that's why we have higher net profit. So I move to the seller side. Let's talk about the publisher. Let's talk about the even this whole ecosystem. Is there something missing in the whole ecosystem? This graph didn't work. So something wrong with the slide. So anyway, the original slide that I have was that we actually did a bit of study on real-time bidding, and to measure the volatility of the bid price for a given campaign. We actually find the CPM price is extremely volatile. Not to mention, for example, the click-through cost per clicks or cost per acquisition. So it's very volatile marketplace. And again, compared to the financial market, if you look at the financial market, the real-time bidding is really a spot market, meaning that you have something to sell and you immediately want to sell it. In that impression generated, you buy it at the real time. So, I mean, if you look at this sponsor search, it's somehow also spot market as well, meaning that when these actually users search that particular query words, and there's auction going on, and then advertiser has to pay cost per click. So in most cases, the advertiser cannot buy that particular keywords by some impression in the future. So there's no sort of a mechanism for that, or at least in an automatic way. So because of that, then there's no principled technology to support what we call efficient forward pricing. So because everything is real time and volatile, how about forecast the futures sort of pricing, and how can you manage the risk? Because in real time bidding, it's not necessarily guarantee you will get that particular impression. If you think that impression valuable, they not guarantee you could get. And also not guarantee the price at all. So we think that if you look at this financial market, that you might have really two solutions for that. Is that adding the additional exchange on this RGB ecosystem, where the DSP, SFP not only connect to the real-time spot exchange, but also connect to these we call it forward, futures, and option exchange, where you can actually pre-buy some inventory. The publisher actually can pre-sell some of their inventory in a programmatic way, not in a manual sense, but in a more programmatic way. So that's the one of solution. Or that's a two solution. In fact, there's a two solution. One is that the forward market, meaning that it's not necessary to be tradable. So it's that you have, might be we call it over-the-counter sort of a marketplace where the advertisers has some sort of a negotiation with publisher and to pre-sell some inventory, but in a more programmatic way. So by doing this, the advertisers are pretty happy because locking their price and locking down the number of impressions they want. And for advertisers, publishers, good because they got some additional, they got the money in advance. And if you take it more, further, is that to make this more efficient, make it more transparent, you can actually standardize this forward contract. Then it becomes a futures contract that people can actually trade. And they might come with sort of options contract where, say, you can using the agree to buy something and then sort of using that to managing your risk. So I'll talk about the two solutions here. So to understand how it works, let's first understand how the ad served in the publisher website. So it's usually publisher has a web server that's managed by, for example, SSP. And there's some quite few ways of sell their impressions. So this always start with a direct sale, direct orders. Some of the menu where they have manual negotiation with premier advertisers. And for something, for example, you have 20 impressions. You sell this 10 impressions directly with some advertisers. And then you have something left. You go for this called programmatic orders, which is more like a programmatic way to direct sell that to the advertiser. And after that, anything left, you go for the real-time bidding. So in this, we call it waterfall. You have this sort of hierarchy of way of selling this. At the current stage, it's that direct is more manually done, whereas RGB is fully automatic, where you can do the targeting, where direct is more or less brand type of advertising for brand awareness campaigns. Sorry. So we're actually thinking for the advertiser perspective, in fact, you could unify this all kinds of way of selling their ads. You need to decide is that how many inventory you actually can pre-sell it and what they are. And you can figure out the percentage pre-sale ads and the one put in real-time bidding. And also how much you should set in both cases. In real-time bidding, obviously you can set out the floor price, where in the guaranteed contract, in the direct contract, you can specify how much you are willing to sell that in advance. So if you do that, mathematically what you can do is that you can formulate that, try to maximize your overall revenue generated from that impression. And one is coming from the pre-sale ones, another one is coming from the real-time bidding. So you can do the optimization again. So we actually did a sort of simulation and find out if you're using that algorithm and find out the price curve for pre-sale the inventory. You can see that the graph on the left. So that at the end, it's put it back to the real-time bidding. But in the very beginning, you can actually sell in a relatively cheap. And when this, the time approaches, you actually increase the price, just like the airline tickets that you can actually increase the price. until that certain point that you're not going to say guarantee anything, to put it on real-time bidding, the price actually drop. So we show that in this case, if you have that dynamic pricing scheme, you actually optimize, actually it's quite optimal in terms of maximize your revenue. So this is basically so to tell you that as a publisher, you can allocate some of your impressions, put it on the forward market, and price it and sell it to the advertiser. And this algorithm would help you from that. Another solution is that, as I said, a futures market. And one of the challenging problems is that what sort of price if I'll sell it as an option. So I would better talk about what is ad option here. So to give a publisher and advertiser, give the advertiser a bit of flexibility. So advertiser basically can say that I can give the advertiser the right, but not obligation. So you give the right, but not obligated. You need to buy our impression, but you have the right to buy that particular impression at a particular time in the future with a fixed price. So in order to give you that sort of right, then you need to pay a bit upfront fee to me. So that upfront fee is called option price. And for that particular contract, you pay the money, I will give that particular contract. And in that contract, I specify the fixed price if you need it in the future. And then that fixed price is called strike price. Also, you have this sort of expiration date as well in the contract. So it's beneficial for advertiser because it secures their impression delivery, reduce uncertainty, and cap the cost. And the publisher is that you sell the inventory in advance, and you got some money, stable, predictable revenue, and increase advertiser loyalty as well. And so by doing this, you will actually create some sort of instrument so that people can hedge their risk based on that. So there are many ways of using this by drawing some sort of studies from the financial market. So the whole, if you have that, with whole knowledge from the financial industry can be applied in this case. So here we give an example how we can use in the sponsor search case. Suppose that the online advertiser, have sort of for sort of a plan that's their campaigns. Let's say they want to buy certain keywords, but they don't really know what exactly keyword they want to buy in the future, but they can specify a set of keywords. And they also can specify, for example, what sort of fixed price they want to have and how many of the clicks they would like to have. And send it to this sort of exchange, send it to the, send this request to the search engine. So search engine, what usually do is they conduct the auction, the second price auction, a generalized second price auction. But they can also set up a pre-agreement with this particular online advertiser, say, okay, if you give me that upfront fee, let's say in this case £5, I will guarantee you will get this, MSC websites with certain fixed price in 3 months' time. I will get you, for that particular keyword how much. So search engine can do some sort of calculation to figure out. And then how to use it. So the online advertiser, when for the following 3 months, is that they can exercise that right. So say if you look at the market, say, okay, yes, the contract that I signed, the current market is very expensive. I want to exercise my contract. So they can basically say, I would exercise that, get that impression, and with that fixed price. But it might be cases that in the 3 months' time that the price actually goes down. So this is the benefit of the option is that if the price goes down, advertiser does not necessarily to buy that number of impressions, the number of clicks through engine, through that contract. What they do is I just forget about the contract. So I pay the £5, I'm lost. But I'm gonna, because the current market is much cheaper, so I'm gonna still through the generalized second price auction, I do that. I pay that auction fee. I run the auction, so that might be the price is cheaper than I fulfill my contract. So give the advertiser a bit of flexibility on that. So they can use it to lock in their profit. So they can find a way to lock that. they can decide that I will not exercise that option. I'll just buy over the spot. And so this graph basically shows that from the publisher perspective, they can using this combined with some of the inventory. They can put it as options to pre-sale it. Some of them are still put it in the real-time bidding or sponsor search, generalized second price auction. They can have this managing their revenue. They can balance it in terms of risk and reward. So this graph basically shows they can do that. And also, we run a simulation to find out, in fact, depends on this fixed price you come up with, and you might have a different sort of revenue from this the option contract. And so this is really my last slides, and I would like to sort of thanks to my students in my team, as without them, obviously, I wouldn't be able to conduct the work. And also, I put this additional information. Should you need any, find interesting, want to look at the papers, look at how actually works, and look at this the algorithm, and then please look at that. And if you have any questions, and I'm happy to answer it now. Thanks.
Thanks a lot. So I hope there are some questions. Any? Yes.
Thank you. This is a great talk. I'm not really involved in advertisement industry, but I have a lot of experience in financial industry.
Yeah.
I'm used to work for one of the biggest market makers and arbitrageurs at Russian markets, and I'm really surprised that there is a lot of similar things. And I have a lot of questions, but I'll ask only a few of them now. First of all, my question about reverse engineering. So if there is two advertisers, A and B, and I'm advertiser A, how could I extract data from public information about strategy of advertising B if we are in the same industry, for example, fashion? Because if I can do it, I could a lot of things. In financial industry, they are not legal sometimes.
But you don't even in financial sector, you don't really know your competitors there.
Yes, but sometimes I can instruct data about strategies of my competitors. Is it useful in this case? So could I find in this information some bids up or down of my competitors? So I could, for example, bid up, my competitor will bid up also, and I can use more later the low price. No, so, I can find some strategies. Is it useful in this industry? But because sometimes we use it in financial markets for our strategies.
Yeah. So I guess the question is that in the financial market, that you might be able to extract information, therefore you understand your competitors, and we will come in with a better strategy, right? Is what you ask whether that's possible in the AdWords. Yes. So I think in terms of transparency of the market, I would think that's probably would be one of the biggest difference between financial market and AdWords. So the AdWords, although it's sort of, you can consider as real-time bidding as a sort of spot market, but in terms of transparency, there's not too much similarity between these two markets. For example, in these advertisers, they obviously, if they have their own tracker, they would be able to understand their performance, their impression, their bidding by, for example, have their own trackers or buy some impression log from exchange, but that only limited to your data as well. So in other words, that it's sort of closed, that you only have the local view about things. But we want to create is that, in fact, we created sort of a spin-out company from University College London. It starts to sort of build this sort of future exchange, try to encourage people to put together information. So that will be helpful for everybody. To try to make this market more transparent. We want to create some sort of futures price curve index so that everybody can use it to benchmark it, to able to come in with their strategy. And then hopefully we'll reduce this arbitrage and eventually make this market more efficient.
Thank you. And my second question, we use some artificial intelligence techniques to optimize our policies in market making, statistical arbitrage, for example. This is a lot of similar things for using techniques like reinforcement learning for these strategies. Did you use it, or do you know about academic research?
Yeah. So I have, given limited time, we don't really talk about all our research. In fact, we have we had a paper talking about reinforcement learning, talking about active learning for acquired to explore the data, basically try to learn the model. Because if you look at what happens for our existing, these two papers that I presented, we have very clear, training phrase and very clear predict phrase. But in the real situation, that you might want to sort of combine these two together. In the very beginning, you want to, this initial campaign, you want to immediately this campaign works, rather than spend the money to explore the data, collecting the historic data, and sort of then to improve it. So you can do this in a gradually iterative or interactive way. So that's the active learning is become very useful. Well, not necessarily active learning, but reinforcement learning is very useful. So we actually using this, we call it sort of using UCB, upper confidence bound sort of technique to explore the data and come in with a bidding strategy. So if you're interested, we can send you sort of our paper.
Yeah, we do some academic research on market structure, and we have a lot of ideas, so we can collaborate in future.
Yeah, cool.
Thank you.
Thanks.
Thanks. More questions? Anyone?
Thank you for talk. I have two questions. First one is about the auction design on exchange side.
Yeah.
And it's not clear why why do we need so pretty difficult auctions with hard floor price and with soft floor price. Why it's just why it is not just a second price auctions or on the first price auction, because it looks like that it's not very transparent for both sides. And the second question is about the supply side, about the pre-sales. Again, why do we need these pre-sales? Because if I'm supply side platform, then I can sell something via my auctions, and I want to pre-sale only if the price will be higher than the something average on this auction. On the other hand, if I'm a bidder, then I will not buy something which is higher in price than in this auction, because in this case I can just participate in these auctions directly. So why do we need these pre-sales without auctions? And the same question about the option pre-sales, because then we have to somehow calculate this option price, and it's again not very transparent for I think both sides.
Yeah. Okay. So let me try to remember your question. So the first question you asked was about the why they set up this soft floor and hard floor, make it sort of complicated.
Yeah.
Why not just sell it as a second price per auction and reserve price? So, well, the reason for that, honestly, I don't know, because I'm not one design exchange. But my guess would be, say, there might be the input from the publisher. They want some sort of flexibility and certain control of because the second price auction, they sort of feel that it's a second price auction. People bid the £5, and someone bid the £1 as second highest, and I only get paid for £1. So they might say, can I have some sort of flexibility to control that? So that might be the reason they set up this soft floor. So the real reason I don't really know, but that's sort of what I feel.
But the problem here is that they bid these £5 because it's second price auctions, and if it is first price auctions, then they bid will be less, because if we have some, and if it's open information about this hard floor price and soft floor price, then the bidding strategy will be not truth-telling, and then they will have some incentives to decrease their bids. So in this case, publisher will not get this £5.
Yeah, I think they definitely need to have more research on that in terms of what would be the sensible mechanism design in the real-time bidding scenario. Not saying, not even saying the current real-time bidding setup is optimal or the best. So definitely there's more research on that. Regarding to your question about this, whether advertiser would change their strategy. So in fact, if you look at the specification, the publisher can reveal their floor price, but it's not obligation for reveal. So that means that they might have the floor price, but they don't really reveal in the bid request. So in some situation, advertisers don't really know there's a floor price there. So the design here is it's a bit strange. So, but I think it's really definitely need to look at in various of situation, in various of setting, what would be the best one in what situation. And I'm seeing here talking about one of the configurations here in terms of these auctions. It's not necessary to be universal either. So we actually study in one of the chains is using specific this setting, but it's not necessarily Yandex gonna using the same thing. You have the floor price. It's not necessarily to be other exchange using the same thing. Yeah.
Okay.
And what was the
the next question was about the SSP.
Why forward market, right?
Why do we need these pre-sales?
Pre-sale. Yeah. So this is, if you look at it, historically, it's the forward market exists. It does exist already, even before the real-time bidding happens. So the forward part is really as there's a negotiation. There's negotiation between premium advertiser and premium publisher. So you do this through the form over the counter. So in finance, people would call it over-the-counter market, where they negotiate by two parties and have agreement in terms of that particular contract. But that contract is not about now, but about 2 months time, 3 months time, maybe a year ahead. So it's not something that we invented, but it's something happens there. But what I try to say, and in fact also the market is moving on that direction, they call it programmatic direct, they call programmatic guaranteed, is that how can we save these labels, save the manual process? I do this in an automatic way. So people try to build a system to facilitate that. So that's the natural growth of that. Did I answer the question? I'm not sure.
Just it probably it's now decreasing. I just I don't understand. Okay, I've got that it was in the past and probably it's existing right now, but maybe it's just will decrease in in the volume in the future.
Yeah.
But if we talk about some programmatic ad selling, then it's unclear why we need this pre-sales, because if we care only about our revenue optimizations, then we will just use the way which will give us the maximum, and usually it's
you can't do that, because really, if you look at the real-time bidding, for the publisher perspective, it's really last-minute sale. It's very stress sale as well. Meaning that if you don't, nobody bid, basically that impression is useless. And if you look at reality, is that most of publishers, especially premium ones, they already have the pre-negotiation with the premium advertiser. And in some cases, majority of them have already have the negotiated contract, already sold their impressions. Yeah, those in real-time bidding really is the leftover ones. So for example, we're talking to some of our premier publishers in our trial. In fact, we basically said that real-time bidding is not necessarily our cool things, because they already sold most of their inventory in advance. And some of other people are still sort of try to lock their door to try to buy additional impressions in advance. So for them, really the real-time bidding is very tiny small bit of that. What they really want, desperate one, is that from that human negotiation, they can't optimize. They want to have this in a programmatic way, similar to real-time bidding, so that they can actually optimize the pre-sale.
Thank you.
We have time for more questions. Anybody? I have one short question, actually. So your algorithm for optimized bidding, real-time bidding, took the first place in this competition from IPNU, right?
Yeah.
And do you have any idea what were the competitors? What algorithms did they use? Was more sophisticated than yours, or just simpler algorithms?
So what was the question? Can you?
Do you know about the other competitors? I mean,
Yes.
in this competition, what algorithm did they use?
Okay. That was probably 2 years ago. I can't remember exactly what the situation was. But so that competition was run by one of the largest Chinese DSP, and it's in fact quite popular competition. It was quite popular competition, and they have teams from 8 countries, if I remember correctly. There's few algorithms, if I remember correctly, that we started with a sort of a linear transformation from CTR to the bid price, and find that they have some performance, but it's not really good. So we sort of change that to sort of saturation function that we derived. And other people try to using some of the non-linear ones, but different people have different way of doing it. Some people even not really saturation function, but the other way around. So I don't know exactly what the algorithm use, but the main one is really the linear one. So just have the linear transformation from CTR to this sort of bid price, and try to turn that particular constant. And also, obviously, if you have very good CTR estimation, that would help as well.
And did anyone try to use this closed form solution, but some machine learning thing with the features?
Yeah, so
and stuff?
machine learning is being focused on coming with a good CTR estimator. So I know people using the digit tree, people using random forest, people using the logistic regression. So obviously they're pretty typical regression that can be used for this kind of CTR estimation. Yeah.
So any more questions? Yes.
I have a question. If you are talking between trade-off of pre-sales and real-time bidding, what kind of risk publisher face actually? So why actually publisher need pre-sales. So why they can't just sell all the volume on real-time bidding? So it's because of capacity of the market, or how could you explain?
Yeah. So, I mean, you could look at this from dynamic pricing perspective. Is that different impression has its own value and therefore has its own price. That means you might have different way to sell it. So for real-time bidding, the benefit really is that is the cookie data. So people tend to buy real-time bidding impressions because it's cheap. At the same time, you would be able to using cookie data to do the targeting. So this is basically a type of impression you usually see in real-time bidding. For those pre-sold impressions, you will see that in most cases they are, for example, the front page banner in the major, for example, publisher websites and major news portal. So these are the very valuable. Some of them even like, £100 CPM. So even more, some of them even more than that. So these are very valuable ones. The publisher really want to control the price and also need to control who are the advertiser that eventually put their ads there. So they have, you don't want to have the bad or sort of advertiser damage their image. So they need to have a control. So the pre-sale ones provide that sort of guaranteed, not only the price, but also that control. So that's why I can see that already there are two types of impressions. For these premium ones, really is a display ads, so meaning that you don't really care about that particular user. You might need to have obviously focus on population of user, but you don't really need to target that specific user. What you really want, you want to have reach, you want to have a brand awareness for that particular population, not particular user, but particular population. For example, I'll give you an example. Let's say McDonald's, they want a Nike, or they want as instead of direct convert, they don't really care about the conversion, but really they really care that the brand awareness of the those users. So what they do is pick up those premier publishers, looking at their population. So I would say, I want to talk to young people, and I want to generate how many exposures, impressions on this all the major publisher in, for example, in Moscow or in London. So this type of things, it only happens, in most cases happens in the pre-negotiation forward market, because it's very suitable for that, where these leftover ones, the page 5, 4, on the corner, those things are left over, not really people use it, unless you have user cookie data, you basically go to real-time bidding.
So if I'm a publisher, so just to simplify, create my strategy, so I sell all pre-sales volume I can sell, and then the rest I throw to the real-time bidding.
Yeah.
So how it's correspond to your model? So you know that the function is different, so we do not maximize. Like if the price for pre-sales is almost in every time is higher than for real-time bidding, so it's like a very simple strategy. So we do all the volume we can pre-sale, we pre-sale it, and then the rest just for real-time bidding.
Yeah, so that's might be one of the strategy, but you might have more data-driven strategy. Is that let data tell you how much you put it on the pre-sale and and what is the price, how many of them put on the pre-sale and what is price, and how many on the real-time bidding, and what is the floor price. Because the algorithm would tell you. The one of last the paper I presented is actually provide you sort of a solution for that to say at certain time how many of them you can pre-sale and what is the price. So you can start to negotiate with that price, and eventually basically show that model help you to maximize revenue.
Okay, thank you.
I think we can continue if anybody has any question. Okay, so maybe you can just approach Jun right after the presentation. So let's thank again. Thank you.